Welcome to this economics class, and we are dealing with the producer's equilibrium. Today, we are likely to explain producer's equilibrium by maximizing the profit. In the last two classes, we explained producer's equilibrium through two ways, by minimizing the cost and by maximizing the output. So, those were the two different ways to explain producer's equilibrium. Today, the same condition of equilibrium would be obtained, but in this case, producer is likely to maximize its own profit. Now, in this case, come on the diagram. While the producer was minimizing the cost, so cost was the variable and output was the constant, fixed output. The producer used to minimize the cost for a given level of output. Second, what we saw in second case, output was the variable and the cost was constant. That means that producer was interested in producing any given level of output at the minimum cost, or producing the level of output for any level of cost. So those were the two theories, different theories. Today we shall be explaining producer's equilibrium when producer will be maximizing its own profit. Now come on the diagram. In this case, cost and output both becomes variable. The producer has the various cost options as well as he has own IQ map. To maximize profit, the producer would move on his expansion path. Expansion path passes through the different points of equilibria, and if the production is taking place under constant returns to scale, expansion path would be linear and it will pass through the origin. That is the case. Now, producer is at the different point of equilibrium. He compares different equilibrium, different output, different cost with different profit, and then he chooses one point as his own equilibria. So this is the case. Now come on the theoretical side. This is production function and this is cost function. Now, since we have to maximize the profit, we would have to define the very profit function, and this profit happens to be the TR minus TC. TC, this one is TC, and TR, PQ into Q, Q multiplied by its own price. So this becomes TR. Now this is TR minus TC. Now the main problem stands as maximize pi. This is TR minus TC subject to output constant. Now this could be written as Q minus FKL. Now as before, we just make the Lagrange function. This is TR minus TC and this is constant. Now as far as the first order condition is concerned, slightly it is different. In the previous two cases, we did have three partial derivatives which were equated to 0. In this case of profit maximization, there are four partial derivatives which are equated to 0. The derivative of B with respect to L, K, lambda and Q. These four first order partial derivatives are equated to 0. Now this is differentiation with respect to PL, L, that is minus PL, and here comes minus lambda, and differentiation of production function with respect to L, that is 0. This is a differentiation with respect to PK. Here comes minus pk, and once again minus lambda, and again differentiation of production function with respect to capital, and this is delta v by delta lambda. So this is q minus fkl, and finally v is differentiated with respect to q, and this is pq plus lambda equated to. So we have four equations. Now from first two equations, minus PL, and this is taken to that side, this becomes lambda delta FKL by delta L. As already I have said, this is marginal productivity of labor. So minus PL is lambda into MPL. So lambda is minus PL by MPL. Similarly, from equation 2, we have minus PK equals lambda delta FKL by delta K. This is MPK. So minus pk is lambda into mpk, so lambda is minus pk by mpk. Now these two values of lambda must be equated minus PL by MPL equals minus PK by MPK. Both minuses are being neutralized. And now if this is reciprocate, it is MPL by PK equals MPK by PK as before. This is the equilibrium condition for producer's equilibrium. And as far as the second order condition is concerned, these two second derivative has to be negative, and FLL into FKK is greater than F square LK. So this happens to be a theoretical explanation of the map of the maximization. Now let us solve a sum on this. Yes, this is the sum, rather a beautiful sum. This is the production function. Q equals 12 minus L plus K by LK, and we are given these three informations. This is price of labor, this is price of capital, and this is price of output, because we are going to maximize the profit, so we must have the price of output. Now let us see first in the diagram. At this point, profit is maximized. Both of the conditions are being fulfilled. Now what we are supposed to calculate, to reach this point, what amounts of two factors would be used by the producer? One thing. And secondly, to maximize the profit, how much output will be produced? These three informations have been sought in this sum, and when we get the values of these three, we are able to maximize the profit. So come on the sum. This is TC function LPL plus KPK. LPL is given as 1, so this is 1L, that is L. KPK, PK is 4K. Now TR is price of output into output, so P into Q, and the price of Q is already given as 9, so this is 9Q. We have got the TC and TR. We must define this profit function as named by pi, and pi happens to be TR minus TC. This is our TR minus TC. Now the standard sum could be written as maximize pi 9Q minus L minus 4K subject to output constant, production constant. So 12 minus L plus K by LK Q. Take it to the right side, so this becomes Q minus 12 plus L plus K by LK. Now first order condition requires that the derivative of B with respect to Q, L, K and lambda, these four partial derivatives should be equated to 0 as it has been done. This is delta B by delta Q. 9Q differentiation 9, once again Q differentiation 1, so this is plus lambda, so 9 plus lambda 0. Now differentiation with respect to labor, this is minus L, differentiation is minus 1 plus lambda, and here we differentiate with respect to L by quotient rule, U by V. This has been done. Similarly, with respect to K, that is here we have minus 4K, so we have minus 4 plus lambda, and once again it has been differentiated, and this is delta V by delta lambda. So I think that one separate class of partial differentiation should be held for the students if they are having the problem. अगर आपको समस्याएं हैं तो या तो कमेंट्स में पूछे हमसे, और लग रहा है कि जैसे आई विल मेक अ सेपरेट वीडियो ऑन partial differentiation, the different forms and how it is done. Anyway, that will be done in another class. Now, with the help of these four equations, we start with 1. Equation 1 says that lambda plus 9 is 0, so lambda is minus 9. This value would be used further. Now from 2, minus 1 is taken to that side, it becomes plus 1, and this is solved. So we have lambda and into lambda का value already we have minus 9, so minus 9 into minus k square by L square k square. K square is cancelled, this becomes minus minus plus 9, and L square is taken to that side, so 9 equals L square, so we have got the value of L as 3. Now from equation 3, minus 4 goes to that side, it becomes plus 4, once again it is solved, lambda, and we have minus lambda by k square, minus lambda by k square, so k square goes that side and 4 comes here, so it is minus lambda by 4 equals k square, minus lambda minus 9, 4, it becomes 9 by 4, that is k square is 9 by 4, so absolutely we have got the value of k as 3 by 2. And finally, from equation 4, Q equals 12 minus L plus K by LK. We are having the values of L and K. We put the values of L and K here. So it becomes 12 minus 1, 11. So it is the value of 11. So we have got all these three values. How much labor is to be used, what amount of capital is to be used by the producer, and while maximizing the profit, what would be the amount of output to be produced by the producer. So these all three informations, and second order condition, simply this has to be shown, and this is what we solve the sum of profit maximization within the producer's equilibrium. I have explained the three cases of producer equilibrium, three ways how producer's equilibrium is defined in detail. I have explained it theoretically. I have solved another sum. Now it comes to the end, this producer's equilibrium. Now finally, while leaving this chapter, I would like to make a comparative and symmetrical study between consumer's equilibrium and producer's equilibrium, which I shall be doing in the next class. वहाँ आप देखेंगे, दोनों को हम एक साथ कंपेयर करके दिखाएंगे आपको, जो एक तरफ कंज्यूमर इक्विलिब्रियम है तो प्रोड्यूसर इक्विलिब्रियम है, दोनों कर्व है, क्या है नहीं है. तो फाइनली बाय द टाइम वी विल लीव दिस चैप्टर, वो उसके बाद हम OR की तरफ जाएंगे, जहाँ की लीनियर प्रोग्रामिंग चैप्टर में काम करेंगे. बस आज के लिए इतना ही. दैट्स ऑल. थैंक यू. Right. Now, to know the maximum amount of profit, how much profit would be earned by the producer, just we have maximized the profit. So, we seek the profit function. Here is the profit function, 9Q minus L minus 4K. We do have the values of Q, L and K. We simply put these three values in pi function, and this 9Q minus L minus 4K, 9, Q value we have got as 11, minus L is 3, minus 4K is 3 by 2. So this becomes 3, and this is 3 into 2, 6. So 99 minus 9. This is the total amount of profit to be earned by the producer with this production function and this cost structure. This is what. अब नेक्स्ट क्लास में फिर कंज्यूमर्स इक्विलिब्रियम, प्रोड्यूसर इक्विलिब्रियम को एक साथ कंपेयर करके दैट विल बी क्लोज्ड. देन वी शैल गो इन ऑपरेशन रिसर्च और लीनियर प्रोग्रामिंग. थैंक यू.